Hello everyone, welcome to another stream. How we all doing? Welcome. So today we're going to carry on with the constructing the volume using the shaders, and we should hopefully get something compiling and maybe start trying to run the first sets of shaders again and getting those running. We've just got to finish off like one or two more shaders basically, and we're right at the end of the first one. So it's about here. Here we go. Hey there, Hocus Pocus. How's it going? It's been a while. How you been? So at the end of last stream, we did the shader which generates the lower level of details for the volumes by starting up at the leaves and going up to the parents. So now what we've got in memory is a full-on tree, and what we're doing is starting from the top of the tree, of the LOD tree. Let's probably go to Milton so we can refresh what this thing kind of looks like. So a volume is 256 cubes, right? There's also another thing within it called a cluster, and a cluster is a 4 cubed set of spheres, so a 4 by 4 by 4 set of spheres. And the root node is a 4 by 4 by 4 cluster. This is when it used to be 2 by 2, which is what we've moved away from. This is what we're doing in V2, is we're changing over from 2 by 2 by 2 to 4 by 4 by 4. But yeah, so then we've effectively got a tree going from level 0 all the way down to I think it's L7. Yeah, something like that. So what we've got to do is start at the top of the tree and effectively check to see if we need to keep it. If we need to keep it, then we copy it into a persistent place in memory. And then we carry on down to the rest of the children, basically. Or we do something else where we check. We get this node, check 8 of its children all at once, because each cluster has 8 children. It's a 2 by 2 by 2 set of children. Check 8 children if they need to be kept or not. Yeah, I think that's what we might do. And if they do need to be kept, copy them to a persistent place in memory. And the reason why I might do it that way around is because then you utilize the multiple threads, I think, more. Or do you? So which one is better? So we can either have... You're always going to have one thread per cluster in this make persistent shader, where it's just copying it to a persistent place in memory. So one method is check myself only. And then copy me if that's true. Yeah, I think it's actually just better if we do it that way around. So we have 32 nodes within a wave. Maybe that's not but good. So what is all this code? It looks horrible. It's because we've basically got this sort of like ring buffer or a queue. Yeah, we've got a queue that we put these nodes on and pull it off, and this is what the code folds out into when you don't want to take a cluster off a queue. But I'm just thinking, if we're doing this on the GPU and each thread is going to get a different result back, meaning that if we take, like, do we have to, does every thread have to take before any of them can be processed? That might be quite slow. Whereas in previous shaders, this was okay, because a single wave, right? Or not even a single wave, it's more of like a single thread group. All got the same item from the queue, because we said, hey, if we're the first thread, go and grab the item, the rest of them will wait here. And then when the first thread is finished, they all grab the same cluster. Whereas this one is saying every thread gets its own thing from here. And because 32 run in lockstep together, they might not break. Yeah, I've got to think about this. Do we have to wait till all 32 threads have got an item before it even leaves, or does it? Yeah, probably will work that way, and that'll be bad. Hey, Gutist, welcome. Thank you so much for the sub. How you doing, my friend? It's been a while. How you been? So, yeah, I think maybe this sort of queue system, actually, I didn't think about this. Doing it this sort of queued method is probably... We could do this, right? Where you say, hey, 8 children. So you just do 8 threads. So you are going to have so per thread group, you only have 8 threads, and then that checks 8 children, and then copies 8 children over. Now the problem with this approach is that you are going to have a lot of inactive lanes, right, in a wave 32 compute unit. But that's probably okay. Yeah, we can see how bad it is. Like, at the end of the day, this is only going to be called once whilst you're building the volumes, and you only build these during like a loading point during the game. So it's not that bad of an idea. Should be alright. Doing well. How am I doing? I'm doing alright. Glad to hear you're doing well. Yeah, just been, been working, getting back into work. This week was my first week back from holiday and back to work. And yeah, it was the first day or two. It was a bit of like, system overload in my brain, because I'd been on holiday for a whole month, and then I come back, and then I'm sort of working. I'm sort of thinking about stuff around the house, and I'm thinking about doing the stream as well. And it's stuff I always doing fine before. But obviously, because I've taken the break and then come back, it's just a big shock. trying to sort of do like complex stuff, programming at work, and then just anyway, it's kind of a lot. But it was alright yesterday. Yesterday was good, and today was really good. So I'm back in the swing of things now. But there's 2 sort of days of catch up, I think. Also, I was kind of jet lagged as well. But yeah, things are going good. But yeah, hopefully by the end of the next stream, so on Sunday, we should be able to get a volume rendering with like, effectively like a nice block of 256 cubed of spheres rendering on the screen that we can then sort of build up from there. Just finish the next feature and the next feature that sort of makes it better. And actually test the performance of this thing compared to the previous version we did, which we threw away right away. But yeah, it's good. What ones are scary? They're right. Yeah, on GPU, especially scary. I think. Oh my days, Glorious, thank you so much, sir. Thank you for the sub. Didn't you just sub last stream? Thank you so much. That's why you subbed last stream. Thank you. Appreciate it. Maybe you didn't, because you're saying 10 months. But yeah, appreciate it. How have you been? Yeah, so back to the wall, the infinite loops, the wall of one. Before we run this, we probably want to put like a max iterations, because I have a feeling that we're going to fail that, and then that will crash my GPU, crash the stream, and yeah, so we will probably actually amend that. Yeah. Yeah, so that makes that better. That's good. So we want to know if we're keeping this. No, how do we know if we're keeping the node? No, this node. Oh, but the first node needs to get copied over. Maybe we do that in the initialization here. Yes, in the volume reset. This actually should do the first copy. So volume reset is actually a really bad name. We should probably call it instead volume cluster tree make persistent probably you could call it reset or start, or setup. So it kind of sets it up, right? Right. So we're going to change that inside this CPU side as well. Here it is. And just got to get that right. Make persistent setup. And this enum gets generated by the compiler, and then so we just compile it into the source code. Yeah, so that will then do the dispatch for us there on GPU. Right. Yeah, so in here we basically set up the volume and we set up the queue with the root node, but we also want to copy the root node over right away, because you're always going to want the root node, right? So we'll put the destination volume cluster nodes in there. So this will do the initial copy over, copy of the root node. Wait, do I even have the root nodes in there? Source, I need the source ones in there as well. So we copy over the root node, right? So we copy the root node right over there. I think I just popped sub for last month and now resubbed properly. Oh, okay. Excellent. Thank you so much for doing that twice there. Appreciate it. Doing good. Yeah, man. Good to hear. Yeah, doing good, man. Just been settling in, but I'm all back now. Super happy. Been missing doing some streaming and working on this project and also doing stuff at work. Back in the game now. Maybe enum's done, restarting, continue. Oh, what, for the infinite loop or something? I'm not sure. I think I'll just do a maximum iteration. So I'll just do a for loop. And I'll cap it out at something big so it doesn't fall over and die. Yeah, it was a lot to take in, but we kind of got started like... I kind of surprisingly did well last stream. I don't know how I did it. Just picked up on everything, which was great. But yeah, so I didn't really program for a whole month. It's crazy. I remember when I was early on in my career, I'll take a week off or something, and it would feel like I've forgotten so much about how to type. I had a little bit of that after a month, but it wasn't as bad as it used to. Like you forget how to do things. So we should really put that on the CPU side as well. There was some like DST. Yeah, so we copy that to the setup one as well. We also need the... What else do we need in there? The construct process queue as well. Oh, wrong one. Yeah, so put the construct process queue in here. Then we're putting the destination, like the more persistent cluster nodes, and this is the temporary build area nodes, they're the source ones. Then we need to put the sync code in as well. Synchronization. So we want to... Oh, that was some weird copy paste there. So this one's a read write. This one's write only, read only. Oh, sweet. Yeah, let's have a think about that. Yeah, we'll come back. Okay. So that's all set up now. So when we do this shader, we've got 8 threads per thread group, which again has waste, right? Because there's 32. There'll be 32 threads running in lockstep in a wave, and we're only using 8 of those, but that's okay. It was better than the other version was doing. So we take our node. So the first one will be the root node. So this just pops. This takes from the queue. And the first one will be the root node. Then, oh, we didn't work out where it needs. Oh, we did. Yeah. This works out where. Right. So this is saying, does the node have any children? Yes, it does. Copy all of the children over. So we need to be able to say, oh, if you're the first one, if you're the first thread of those 8 threads, we want you to allocate 8 in a row. I think they should be tightly packed. Yeah, it should be alright. I wonder if the root node. So the thing I'm curious about is. Should we start this off at 1 or 8? And also 8 is not a good thing just to write in. It's a magic number. And, you know, because we program in C, we don't like magic. We'd like to know what the magic is. So it's a cluster children count. So the thing is like, so we allocate a range of, we still need to do the custom allocator, right, for these volumes. But we're also not writing that yet because we're not solving that problem right now. That's a future problem when we get stuff on the screen. But we've essentially got a range of nodes. Now, we could, I haven't over allocated this. But yeah, I'm thinking should the root node. So effectively right now, right? These 8 nodes. Like the 8 children. The child 0, 1, 2, 3, 4, 5, 6, 7. I think I double typed some of that now. Yeah. So they sit contiguously in memory. So we just point to here. And then we know all of the children nodes sit next to each other in memory. This saves us storing 8 integers within a node. And keeps the nodes smaller, but we waste space by having all of the children allocated, even if they're not. What I'm thinking is the root node is just a single guy. Now, when we was building it in the building space, we actually made it have a bunch of blank siblings. So they were all aligned to 8. And this is because of the custom allocator we had. It was just a bump allocator, bump to 8. So I'm thinking we don't have that problem anymore. So we can just bump the exact number But the alignment is going to be different, and I wonder if that's going to have any implications. So we're just going to think about that. Hey Downsy, how's it going? CA is the magic. Okay, screw you. White House, exactly. I cannot believe. Yeah. And then like on Twitter you get people speaking about just more nonsense stuff about that White House thing. Yeah, it's fun. It's kind of interesting how they expect everyone to like adopt a safe language, like they haven't got massive code bases or don't have different requirements than other people. It's also interesting how they don't try and tackle the memory safety problem from a different angle. Instead, they want to say, hey, all of you 500,000 people who program, change the way you program. Versus like saying, hey, why don't we, you've got like limited a number of hardware vendors, you've got a limited number of operating systems. Why don't you try and tackle it from that angle instead, right? There's less things to change. It's just weird. Hey, Type Beaver, what have you been up to? I've been in Australia. I've been down under. That's what I've been up to. I've been outside, getting out in the sun, absorbing all the vitamin D for the year. Twitter is insane nowadays with all the NSA thing. What NSA thing's going on Twitter? And heard about it. About that. Oh. But yeah, no. When I go on Twitter in general, though, I'm getting a lot more normie stuff pop up now. So I had to like go through and like say, hey, I want to ignore this normie stuff. Like it's just such random stuff because I just gone to Twitter for like tech stuff. But I'm also getting like tons of stuff about AI or LLMs and all that crap. So I have to do the same thing again, go out and clear all that out. And then as well, there's for the past like month or whatever, there's been people just like talking about like absolute like yeah, just regular rubbish. To do with C programming and other things as well. Just like it just gets to the point where you scroll through and just come across so much stuff you just disagree with. You just go and do something else. Adopt Rust. Ignore the software supply chain issues of the worldwide show public insert stuff into crates. All good. Yeah, they are. Yeah, it's just crazy the level of ignorance they have basically of just how the world works. 6 for 5 God, exactly. All the C campaign. Yeah, I'm doing good, man. Doing good. Got myself a Pepsi Max Cherry, but it's nearly all gone. And it's kind of hilarious that they consider memory safe languages that are allocating every freaking variable in the heap. Yep. Yep. Memory safe languages that create a lot of garbage. Literally. Vim colors. So I've based it off of something else, but then I've like applied it in so many more places, and I've tweaked it a bit. Oh, I've got a thing for that. I think I can just do this. Past me has, yeah. Look at past me go. I think that still works. There we go. That's what I did. Hey, collector of stuff, how's it going? I was going for dinner. I was going to get dinner started, but I'll be back in a bit. Alright, see you in a bit, Dowsy. Good to see you, my friend. Right. Yeah, so I don't think. So let's just take a look at the size of our volume. So, no. Volume cluster node. So that's one uint, one U32. So 3, 5, 6, 7, 8. So we've got 8 times 4, which is 32, right? So that's half a cache line. Well, you hope GPUs use 64 byte cache lines, but anyway. So I'm just thinking, if we miss by 1, yeah, I don't think it's not a problem because they can't wait. If we're off by 1 node, then we'll be in the upper cache line. Yeah, so that means then these siblings, like if we don't add an 8 offset, this will be in a cache line with this root node. These will be in a cache line, these will be in a cache line, these will be in a cache line, and then this one will be in a cache line with the one that's the other node that sits, set of nodes that sit to the right of it or something like that. So that's kind of bad, whereas if we add the padding, right, so the root node would just be by itself at the moment if we do it this way. We start off as at 1. But if we start off at 8 and we put this sort of like padding down, where there's just going to be a bunch of blank nodes at the start that have nothing, it's just wasting memory. Then these two will be in the same cache line, these two will be in the same cache line, these two will be in the same cache line, and so will those two. I don't know how much better that would actually be, but we can always see how much better that is. So what I want to do is right. So we're going to see how. So this is cluster children count. So we'll test how much better this actually is, right? One of them just starts off at 1. The other one to see how much better you don't even have to allocate an extra 8 though. You could just allocate an extra 1 and waste it. And it all depends if we sort of make this any bigger than it actually is now also. If we align cluster nodes to a cache line or whatever. If we align all children cluster nodes to a cache line, something like that. So that'd just be start on 2. Yeah. We'll come back and obviously make that better in the future and test it, but that's just something to think about. Maybe it doesn't have any effect. Maybe it's negligible. We don't know. So yeah, so now that's all set up. We go back to this shader, which makes all of the nodes persistent, or copies the nodes from the building buffer into the persistent buffer. So it gets a node. Does it have children? Yes, it does. Bump allocate 8. Have we got a read lane? Let's look at my intrinsics now. Yeah, read thread. Read thread 0. So yeah, the first thread's gonna calculate where the children go. So in the big buffer of cluster nodes. So there's one big buffer that stores all of the cluster nodes for all the volumes that are living in GPU memory. And this sort of reset shader is going to allocate that position, but it's going to do it in the future. We haven't run the code yet. And so we just bump allocate from here on out, since we have our range. The first thread goes from the start, bump allocates 8 of them, gets back an integer, and then we use this read thread. So it reads this value from thread 0. Thread 0 did this, so it's got the value, sends it to all the other threads. And then we need to say plus this. And this would be from 0 to 7 inclusively, right? And then, because up here, this is 8, right? So we're doing 8 along the x. So that would be our source node to copy. Sorry, that'd be our destination actually. Whoops. So we should be able to calculate our source as well actually. Yeah, maybe this should be read source actually. No, that's wrong. Source volume cluster nodes. So the source one is going to come from node dot. I forget this. Children cluster node start index. There we go. Now I need to say plus. Then obviously this child index, we should really call it that. Cluster child index, we'll put up there. Right. Hey collector stuff, you said before this is an off-time project. I can't imagine getting home after work and then start streaming with some super complicated stuff like this. I wonder if you're fine with this being one of those projects for experience, or whether you have some goal in mind. Hey collector stuff. Yeah, so it's kind of like a bit of both, right? It's kind of trying to it's you know, it's ticking like a lot of boxes, this project. So the one of the things is it allows me to get more experience, right? As you're saying there. So in the future, when I'm applying for, when I'm trying to maybe advance my career, this could definitely be something that can help out with that. Also, I really want to build my own. I like writing my own code. Learning stuff outside of work that I don't quite get to do at work. Um, or learning things from a different perspective or a different angle. Um, I also want to finish, or I also want to work on my own game, um, and sort of potentially in the future have the chance to have something that gets made, which I sort of started and laid the groundwork for, and then see where that goes from there. Really have more options basically in the future. Um, you know, it kind of would be nice to have a game of my own that gets made, right? Um, I'm not sure how that fits in with things that are going on currently, because currently I really like what I'm doing as my career, and I don't want this to get in the way of that, because I really enjoy what I do now. But it's just nice to have options available, and but also as well, I like to sort of I'm liking to um, sort of show or keep track of how this project is going, and hopefully inspire more people to do this sort of stuff as well. So it's kind of like ticking all of those boxes in some way, and that's where I'm going with it for now. Um, I'm planning on making the source code available for this, even when the thing is done as well. But yeah, that's basically a list of things. But yeah, so while I was away, I have done a game design for this project, because what I was noticing is I was designing this sort of volume cluster system, and it's very easy for me to like do the most general thing that answers all the problems, and then it gets really complicated. And I sat down in my off time while I was on holiday, and I wrote down a game design document, which is up on the repo for those who are interested. I'm not going to show it on stream yet. I want to finalize some more stuff about it. But when I go to answer some questions, I might open it up, and maybe we'll go over it. But just now is not the exact time. But yeah, so what I like that we've got now is some game design that we're probably going to go with. But so if I have a question about how I'm architecting something, or if something is good enough, I'm going to refer to that design document to see does it help with this game, basically. Does it help us achieve this game and stuff like that. So yeah, this is something ultimately I want to build over the years, right? So I think for now, the main goal is just build a foundation and de-risk all of the issues with the game that I want to build. I'm not going to be able to build the game by myself fully, but I definitely can build the foundation of it and de-risk it as well. And then from there, figure out how I want to get to the next part, right? So that's basically where I'm at with the project. What I'm thinking about this project. So what we're doing here is we're copying the child over Right, so maybe I should drop a comment in here. So this was sort of like, so copy all of the children. So that's the source location. Yep. And that's the destination. Copy all of the children over to... Yeah, copy all the children over, something like that. Now, something that we have to do is, because we've copied the children over, this node the parent node, its children cluster node start index has to be patched to point to the new place. So I've got to figure out how I want to do that. Public value of the stream is huge by my standards. There's not many sources of sane program knowledge these days. Thank you, sir. Appreciate it. Yeah, it's very difficult to also try and document a project like this. I'm hoping to maybe do some weekly updates, maybe like every Saturday. But I need to sort of do a catch up one of those, and probably just do in a video form and just go over some stuff. The problem is, yes, a system like this is kind of quite complicated, but maybe there's, when things have been ironed out, it's easier to speak about and talk about. And just do an odd video about it every now and then or something, you know. Like every week do like a video about some things to do with the code base. Yeah, it would be cool. So I think I have time every Saturday, maybe like an hour or something, just to do a quick video. Because that's the problem, is time. Hi, Colmac Vanilla or DH mod? Colmac Vanilla. Maybe with the caps lock thing as backspace. But yeah. I don't know, I have caps lock as backspace on my home PC, but at work I don't, because I didn't bother doing it, and I'm not sure if I really care about it that much. So yeah, just standard Colmac. How about you, Beat Watcher? Are you using the Colmacs? Or instead of every week, do it when you finish up every system and can explain it. Yeah, I tried to do that. But then the systems would be so big that it would take multiple weeks. And then it would just get, I have to edit the video and it's long. But yeah. I'm thinking about maybe just doing every week, just talking about something that I can just do in an hour. But we'll see. Yeah, exactly. I don't really have a lot of spare free time, to be fair. Just be kind of into like family time and that, so. I think your persistence is crazy. I wish I had that good of a project. Thank you, sir. Appreciate it. Yeah, I do have that sort of mindset where I'm quite persistent and stuff. I just, I don't like giving up. Or just when I'm about to give up, I have all the energy to keep going. It's very weird. AZH wide, but on caps lock I have control and escape. Aha. Glad to see another Colmac user representing in the chat. Colmac is the way, people. It's a keyboard layout designed for a computer, unlike QWERTY and Dvorak. But you will have the pain if you want to try and play a video like a video game on PC, because it's hit and miss whether a video game will support actually supporting well, basically you have to rebind all your keys manually if the game doesn't support scan codes. If they don't use scan codes, then you have to rebind all your keys, and it's annoying. Exactly, no quitter. Yeah, so we've got this sort of like start index thing, right? But the problem is this node would have already been copied into the persistent memory. So, but we don't know where it is, right? Because, so what we need to do is we need to store, after you copy it, we need to store in the node where it got copied to, and then we'll use that, right? So which one can we can just overwrite any piece of information. It literally doesn't matter. I might just put in lock, maybe. Well, no, it does matter because we're looking at some of the information here. But I don't think we're going to look. Yeah, so after we copy it, we're going to write into the source is actually going to be the read write. So we're going to just like kind of mess with it. All right. So what we want to do is store in here. Wait. Lock. We'll put in alloc start index. You know. So this is so we can patch. Store where the node was copied to. So data can be, so the child can be patched. So we need to do that as well. So we need to do that here. As well. So we're going to store DST cluster index, right? Store where the node was copied to, child node was copied to, so that the children can be patched later. Boom. Okay. So what we need to do is we need to say get the, this will be known as the, so we should probably really call this like destination child cluster. Anyway, my music stopped. Right. So after we allocate this is where the children start from. And you've got one thread here only doing some work, so we'll get it to do one final little thing. So we need to reach into the destination nodes, and we need to say, hey, wait, what are we doing? So we need to say node.lock, right? So this is going to be destination cluster index, right? This is where the node was written to, right? Pull out where the node was written to. It just happens to use node.lock. It was stored in node.lock earlier or something like that. So we're literally just gonna when it was copied. Initially. So now we reach into here, patch this with oh wait, what are we patching it with? Destination child cluster index. Boom. So we should probably actually call that children nice long names. Even asked a question. I like you answering the FAQ on why not Rust, but I want to ask, why not Zig? Well, the thing that I like about the C language is that there's not much to it. It's quite simple. You know, obviously it has its issues, but considering how old it is, and considering how like many issues there are with it, it does really well. And it's actually a lot more simple than every other language that's come after it. And all these things that have come to replace C are not replacing C, in my opinion, because they are not striking that balance between simplicity and yeah, like these new languages that come by, they're basically C++ replacements. And yeah, that's it. They're just C++ replacements. They're not simple. They do too much. They have literally beta programming language ideas. Like they're not tested, and they're probably just not good ideas. Like, so, you know, if you use a subset of C, which is not really that much of a subset of C, compared to a subset of C++, which is like huge, you know, which is kind of a whole lot is what I mean. Using a subset of C is just, it's good enough. It definitely has some issues, but it's not the end of the world. You haven't tried Zig, I think. Do I need to even try Zig? Have you seen, like, just look at the standard library and tell me how much comp time is just everywhere. And tell me if that's simple. So right, so we've put that in there and we've patched it. Is that the only thing we need to patch? The bit set. Oh, that already got. Oh, wait a minute. Yes, we cleared that. That's good. The parent node index also needs to be patched. So maybe we need this. So after you've copied it over, we also need to copy over the parent cluster node index. I saw a try word in Zig and I just closed the web page one day. Excellent. So you did try it? I got the wrong impression when you compared it to C++. Like, open up the standard library, look at anything in there that's generic, and just it's too much. Like, it has, what is great about Zig is it definitely has a good way to do stuff. Like, you can let the compiler do stuff at compile time, and like, you know, it's very powerful. But what I would argue is that like it's just too much. Like, you just don't need it. It's cool, right? And it's cool to talk about it, and it's cool to be like, you know, but ideally you could just get by without it, and you can always just write a C program that does some stuff, generates a file, and done. And Zig also has this thing where it integrates with C really easily and all this, but it's not really, like, basically bindings are better than its system. Like, handwritten bindings are just better. It has to have a huge dependency on Clang, and it will have to run Clang to parse all those header files every time you compile. It caches it probably, sure, but equally, you could just have a set of bindings written out, parse the bindings in the language naturally. You'll be able to press F12 or whatever it is in your editor, go to definition and see it in the language code. Yeah, it's just not ideal. I would like a language for with formal verification, explicit communication with the optimizer. Crazy math stuffs I do. Yeah, that's probably a bit over my head. Formal verification, explicit maths, explicit communication. Wants to be able to assert that specific optimizations are made. Interesting. And that leap invariants hold for the code array. Right. I see. So if you write a lot of... Or maybe I don't see. Yeah, I'm not sure if I understand. But hey there, Osmosko, good to see you. Hey, Bean. So we're patching that in there. Is there anything else we need to patch? That's it. Right. So they're all patched now. Excellent. We'll move this comment in a bit of a easier place to see something off the screen. patch the parent cluster. You can just read the code and get that. Well, there's a comment to explain that. Clear the extra bits. That were used during during what? During the refinement. Alright. So that's copied over this cluster, all of the children basically. But we now need to push them onto the queue. So this is the push code. Push each child onto the process queue. So ready for the next thread to come over and do all that. So we need to add one. Now you're probably better off doing, you know, maybe that's alright. But you might be better off doing something like this, I'm not sure. But let's just do this because it's just simpler. We need to make sure this memory is cleared with U32s actually. Shoot, we might need another queue. Yeah, we need another queue actually. Anyway, so we're pushing on this. All right. Just clean that up a little bit. Okay, so if there is no children, what are we going to do? You still need to patch something, right? You need to patch, if there's no children, you still need to reach into this cluster and you need to make sure that you say hey, this children cluster node start index is equal to U32 max. Yeah, I think that's all you need to do. Just say it's got no children. Alright, so I think that's literally the shader sorted out now. I've just remembered there is a problem. Wait, let's just double check it quick. So we just did the copies. Yeah, it was just copying, that's all it was. Okay, it's fine. So what I want to do is we probably need to make another queue and not call it the construct queue because there's a problem. There's a problem and that is to avoid taking from the queue too early before the data is written. We check to see if it's got a U32 max there, because that means an invalid wedge hasn't been filled in yet. So we need to make sure that we mem set these queues with yeah, mem set it with like all bits on, right? We need to one the memory. So where we call it this sort of like construct process queue, we should just call it process queue. All right. So what should we call this? Probably the see, I call it like make persistent, but it's a very long name. I could call it trust cluster tree copy. But then copy makes it seem like you're just moving it around. So I guess we will just have to call it make persistent. It's a bit long, but oh well. It's the way it goes. All right. Yeah, this is some dead code I've just left out. So I think we're good now. We do have to make sure that we clear all those CPU side. I think I mem set, here we go. So the construct process. Make persistent. So we need to make sure that we fill in that one as well. So we'll have a process queue there. So we're using more memory, but it's okay. Should be fine. The closest thing I've used is TypeScript, which you can change the type of variables as they are used in the code, e.g. if you can have a string variable against a value, the variable can have string. The variable will have a specific string as its type. Okay. You can say that you've covered all the cases by calling a dummy function. It takes a never type. Oh. Right, I see. Yeah, there's some what's really interesting is C#, Rust, Java, and a lot of these other languages, they didn't really, and C++, they all have these weird limitations with the type system when it comes to generics and templates, those things. And you can't just simply do like these compile time if statements in a lot of cases, or you sometimes can. And it's this really weird, complicated code, which is basically loopholes with how the language works to achieve what you want. It's like C macros, but on another level. Craziness. So yeah. I went and bought some water at the shop. I accidentally bought some sparkling water, but you know, so now I'm feeling posh. So, alright, did we sort that all out? I think we did. Oh, no. So this should be the refine. This one is the make persistent. So what are we doing here? Clear the queues such that the such that the sort of so we can tell when a value, when the value has actually been written to the queue the difference between, so we can tell when the final value has been written by another thread group, something like that, and can take that from the queue. Okay, so now I think it's just time to get this thing compiling. Wait a minute, I think we gotta, we should be using the queue in the make persistent thing. Let's sort that out. I just got a process queue. Read write. Yeah, I think that's right. Do we need this free indices anymore? I think we deleted that, right? Yeah, it doesn't exist. Okay, so now it's just gonna try and get this thing compiling. That's the plan. Free indices. Cluster node free indices. Right, so I don't think we did. Yeah, we need to change this. Oh. That's right, cluster. Yeah, sphere free indices. Those ones we need to get rid of. Okay. So let's get this thing compiling and then see if we can get like one of the shaders running today. So if I multiply int with 2, I can assert that it's even later on. No. So where would that go? Would that belong with the type int? And you basically say if int is multiplied with 2, assert that it's even. Is that what you're saying? And it'll do that at runtime? Right, let's close that window. Right. Yeah, LOD. Okay, so we only needed these guys. Cluster nodes, process queue. So this is the refined process queue. What else? Occupation map. And the volume spheres. Why do we have volume spheres? That doesn't need to exist. Is this? Yes, it's the old code. Yeah, because we just have a bit set of spheres now, because it's just in a grid when it's in this sort of volumes local space. That's cool. So it's just those three. Sync, sync. Yeah, this code could probably be automated at some point, but yeah, that'll do. All right. We also changed this shader here, the construct leaf nodes. This is the first shader that kicks off. I think yeah, this is probably called the construct one. I think I did sort that one out. All right. So hit compile, and so it compiles the shaders first. So this is my custom C compiler running. It only really does one error at a time because multiple errors, it felt problematic. It felt like most errors would just be would not be correct after the first error. So I was like, I'll just do one error. Just made it easier as well. So yeah, I don't close that function call there. That's the Lexa failing. Whoops. Oh. That's alright at the start of the Did I do that in a few other places? Yeah, there's the copy paste. Right. This one's now failing. Extra bracket, no worries. So this volume sphere, we actually got rid of that. Atomic load U32, I imagine. Cluster location LOD. So I think it's block you have to do. Yeah. So this is just a 32-bit integer. It's got packed data in, so we just fetch the LOD out from there. So this is the one that converts the edit operations into the initial tree, cluster tree. Where the edits come from again? I think it's there. Cluster LOD, highest LOD. Wait, what's the thing? Redefinition. Yeah, that's that can just get deleted. Yeah, because this code here makes the occupation. So basically this used to be a separate shader. And it's at the end of this where the shader that defines the initial cluster tree. And what this does is this fills in the what's known as the occupation map, and basically it's a 3D texture where it keeps track of, it's got a bit set for each pixel in the texture, and a bit set holds a bunch of bits where each bit represents a cluster, and allows us to very quickly figure out if a cluster is surrounded by other clusters. So the bit is on if the cluster is basically full. So it's not completely full, but basically full. So yeah, that's what that code is doing. This one is the refining, so we've got past that other shader now. What was the issue again? Oh. Did we, construct tree. Oh. Oh, I need this in all the places. They use the queue system. So that'll be in refine LOD. So the way these shaders work, right? And they work in a very weird way. But so you've got this sort of like one that constructs the initial tree. This refines it and makes the lower level of details. This one copies it to persistent memory. The way they work is they have a queue. They have a little process queue that, you know, stuff is simply queued on, and you take it from the front. And each thread group takes an item from the front, and then all those threads in the thread group run on that item, and it's usually and it's always a cluster actually. So this is what it's like to take from that queue. But the way we dispatch it is kind of a bit weird. Basically, we just need like our compute units will stay on that same shader for a long time. Maybe we don't need the while loop, and maybe we can just make one instance come alive and process from the queue or something like that, and then do its job, then end. But we have a while loop, so it keeps going. So it'll come back around after it's done the first job and go again. And it goes until every single compute unit is just waiting around. When they're all waiting around, it'll end. Then this stage will be finished. So the maximum number we need to fire off is then basically the total number of compute units on the GPU, which you can't really get this. You can't really get this number, so we've just hard coded it for now, and we might have to do a lookup table for each piece of hardware. So I'm trying to think of a different way we can do this. So basically, just keep all of the compute units busy with this single shader, and if there's too many, when all of them are finished, it will just try and start more of them. But maybe it's only an extra 100 or so at most, or whatever. I don't know if you're off. Yeah, I'm trying to think of a better way we can do it, but it's kind of a But it means we get to do recursive algorithms by basically storing all the information on a queue and just pushing stuff on the queue that will come back to in a future iteration around the loop. And different threads can take the item that you've pushed on to the queue. So we'll see how this goes later on, but for now we just need to fill in this variable. Why is it divided by 2? As you need 2 wave 32. Cross 64. Okay. I think I get what I'm saying there. Is this a wave 32 as well? Yes. Sorry, that's 2 wave 32s. Yeah, it is. I could just call this the process queue. Yep. Let's move that up here. Okay. So on the make persistent one, this also needs it as well, but it's not divided by 2. Because it just uses 1 wave 32, so it needs all of those. Okay. Right. Let me compile again. So made it further down. Right, so we're going from 3D down to a 2D. Yeah, that was a bit of a mistype there. Can I find parent node index? Right, because that's parent cluster node index. Okay, excellent. We're moving on. Test the refine shader compiling. Oh my days. Get it right. No, is it nearly there? There's too many of these buggers. Parent cluster node index. That's the dead code. Right, nearly there. DST. All right. Right. So that's all the volume constructor shaders compiling. Now this is the sphere binning that would simply try and render them. So maybe we should try and patch this one up, just see how easy it is. Yeah, it should be possible. I don't think it's too hard to patch this one. What was the issue again? Volume cluster tree nodes count. That does exist, right? It's just a slightly different name. Yeah. Right. So this safety check doesn't exist anymore. Oh, we're not dispatching over all the leaf nodes either. That was the old system. Okay, so here's what we're going to do. We're going to do something amazing. We're going to disable the code. And we'll come back to it. Because the way the new method needs to work is... oh boy, what have I done? No. Okay, I got myself in a bit of a pickle now. Well, a compiler bug. So we need to locate this compiler bug, so we're just going to disable some code and find where it is. I'm using any bit fields anywhere. It might be just here. So if you read from any bit fields, it's fine, I think. Right, so let's go into the shader where it uses the bit fields. And let's just comment all this code out. Right, still has a problem. So it's not that shader. Is it this shader? No. Refine LODs, is it this shader? There's a Spivvy backend for LLVM, sort of. I'm surprised Clang still doesn't support shader programming in some form. Yeah, I think someone the other day released something, the other month released something. But yeah, I just wrote my own because, yeah, just thought it'd be better. It's a weird thing as well. When you see any other new shading language that comes out, they all basically just take whatever GLSL or HLSL has done, and they're like, just make it work in the language that they're doing, right? And it's really crazy how they don't try and go towards like the future of GPU programming, which is basically bindless resources. But even more to the future of programming is having pointer support. But I didn't do that because not all, like basically on Vulkan you have pointer support since Vulkan 1.2, right, in core, but it's not on other graphics APIs, so I didn't bother doing it. But yeah, like proper pointers and stuff. Oh, it compiled. Interesting. Right, so refine LOD is the bugger. But could this one also have the same problem? No. Okay, so there's some line in refine LOD, which is messing up the compiler, which is sad. All right, so we're just going to narrow this boy down. So let's just pick a place. Let's go past the queue. Right, it could be the could it be the control barriers? I don't know. Okay, that's still compiled. Let's move around. Let's just start accepting more code. There's this massive if statement here. Oh, imagine if it's something to do with this. Let's see if it's something to do with this. It is something to do with that, maybe. Or this here. We don't know. Alright, something to do with the stuff above. Excellent. Let's narrow it down even more. So let's take this out. Wait, sorry. I just lost where I was at. No, I think I looked at it the wrong way around. Or did I? So I bring that back in and it fails. So it's something to do with this? That should... Right, so by the looks of it, we're repeating... There's... The same problem is in both of these pieces of code. No? Alright, so the same problem is in this piece of code and all of this pieces of code as well. Right, so we can actually just narrow this down. Right, so we've got the problem here now. But I do that, problem goes away. Alright, so in this part here, right, we didn't take the address on that load. And it was okay with that? I thought the type system would have caught that. That's silly, isn't it? I thought I had a system that... There you go, fixed it. Well, that's not good. We need to fix that because that will be very misleading. Yeah, I don't have to hunt down that again. Right, so let's open the compiler and see why that is. So what do we... So you... it's getting all the way to the spivvy code generation. Before, so it's already done the AST type checking. Okay. So we're kind of looking for when you call a function. You will parse all the arguments, ensure compatible assignment. Can cast. Did I get rid of Did I get rid of the pointer? Wait a minute. It just doesn't do any. What are you doing? What is this? Check compatible assignment, and if it's not, well yeah, okay, so it's not compatible assignment. Then it'll do the right error. Okay, that's good. So this is failing here. Resolve and strip qualifiers. So resolve, is that gonna, oh, is that gonna get rid of the pointer type? It just says enums and type defs. Don't see it getting rid of any. HL's coming to Clang. Yeah, there would. It's a bit weird they're putting that in there. Yeah, that's what they've been spending their time on for some reason, even though it could have just been a separate product. No, it's, they could have just spent time making their compiler better. You know, I don't know why they had to do that. Because the problem is GPUs are so much more restrictive than CPUs. And you're just making the Clang code base worse by having all these extra if statements for HLSL now. It's mainly because DXD is unmaintainable at the moment. It's built on a really old weird fork of LLVM. Yeah. So one, they brought down on themselves. Two, DXIL is based on a kind of old version of LLVM IR. And I doubt they want to change that to the latest version anyway. But maybe they do. You know, I don't know why they decided to fork Clang and make that project, to be honest. They had probably had a whole team of people and they could have just built one from scratch. But anyway. Yeah, Microsoft, a small indie company, exactly. Well, if it was a small indie company, they probably would have done it, but yeah. So, what am I getting from here? If it's pointer, if it's putter. So you deref the type. Huh? What is this? Oh yeah. So we strip the qualifiers, check if they're equal. Right. Check if the types themselves are equal. That's probably fine. And if the target is... See, the bit that's striking me is how's it getting past this? If the target one that we're assigning to is const, and the source is not const, then source becomes const. Okay. I don't know why this is... Yeah, so it must be landing here. So... what can I do? So, the type is an integer. Yes, the thing it would be comparing against. So this wouldn't even get reached. Because one would be a pointer, the other one would not be a pointer. And then you'll get all the way down here. Then you lower the types. With the pointer even lower? Lowers, okay, just lower the pointer. Into the abstract machine language type. And then it will generate an implicit cast. Oh, that's if it's a resource type. If not, it returns false. It should be returning false. The question is, why is it not? So I think what we need to do is we need to somehow we need to somehow in the sample code, let's go to compute square because that'll be basic. Let's put in, should we do a little bit of LDS? Type def strut t strut t int or uint32t value. So local data store this atomic add u32. Let's do LDS.value, right, not taking the address, this is the bug, and do 1. So let's first of all comment that out, just in case. Then we're gonna, so the thing is, I think there's a script to run the samples. No? Or no, it's just the build script. So that'll just run. Yeah, there's some bugs with the latest version of SpearV decided to mess up. SpearV opt or whatever it is. Okay, so we encounter the same problem here. Excellent. So now what we can do so the problem is it's still part of one massive compilation, but we can maybe find the function it goes in, I don't know. So how can I get this to... So I could open up in GDB maybe. So I don't have the stuff that's in my game code base in here. So I think if we do signal.h, we can do arrays. Is this the argument? Yeah, okay. So the thing that we're looking for is specifically the function declaration, which is kind of an intrinsic. So should we see if we can get the exact one? Decl function. You can get the function value. Probably be some function many thing, wouldn't it? I wonder where this would be. Excellent. So somewhere in between here. Right. So I think we should be able to get a breakpoint to get triggered. So I should be able to say... So I don't know if we use atomics, actually. Maybe we do. Should grab the code base quick. Yeah, only one example. Use it, and that's one we just put it in. So if I say HCC decl auxiliary, so this gets the auxiliary piece of data inside the decl. The decl is just a U32. The first 9 bits or whatever are a type, and the rest of the bits is like an index into whatever. So we're getting the function index. Just saying if that is equal to yeah, okay. So function many, what function are we looking for? The atomic add. So we kind of want it to be on the U32 one, isn't it? Yeah, it's exactly what I'm looking for. Then we'll just raise this again. You're better off not using this function because in the debugger it will break inside this function. You're better off emitting or using one of the compiler built-in. I forgot what it's called. Trap, isn't it? Yeah, built-in trap. That's what you want to use. None of that baloney. So that'll just, yeah, let's send a sig trap instead. Yeah, or a bit of inline ASM. Yeah, that's the other way of doing it. Did we hit it then? No, we didn't hit it? Why not? Oh, times this. No. That's wrong. Come on. Work with me. Trying to land on the exact... Something as U32. I don't know why I didn't open this one in. here instead. Okay, so how am I not... Right, because it's an intrinsic function. Is that right? Is that because it's an intrinsic? Right. So regardless, we're doing... So I could just say, hey, if it's less than user start, where the user functions start, rather than the built-in ones. But I definitely use the built-ins all over the place. So I'm trying to land on the specific one. That should work. Oh, it could be a forward declaration? No, it can't be. Doesn't make any sense. Is it a forward declaration at this point? It must be a built-in. Is it maybe not coming across any arguments? Or something really dumb like that, but it must be. Okay, so definitely hit there. Do we hit here? No, definitely not. I'm confused why. So why don't we just say, hey, if this thing is less and that is less than print out. Okay, so we hit the trap. But how many times do we land in here? Probably too many, right? So what about atomics? Let's do the range of atomics then. I'm confused how that didn't want to work. So anyway, let's say start plus, and then also, so how many atomics do we in the examples, use atomics anywhere. Sample. Where's the samples? Yes, only one sample uses it, so we can just do the whole of, okay. All of the atomics. Then, so let's go all the way up to there to texture load. Alright. Let's try that one. Do we get a hit? We still don't get a hit. I'm not sure why we're not getting a hit here for any of the... So we should print out all of the names of the functions it's calling. And if we put a couple of dummy functions around it, so we can get a function name, can we? Right, it's a string ID, then you'll get the string ID and... string table get. But it's not null terminated, so you gotta do one of them. Sorry, I'm not sure I understand what you're saying. Yeah, I'm not sure what you're saying. Sorry, Mertender 3. I have no idea what this says. Apologies. Why doesn't this... Oh, 2 arguments. That'll do it. Okay. So we'll put a few... Alright, part of the problem is this problem's coming in into standard error, and it's clearing out standard out. So you need to put into standard error, and then it will show up. Assert failed is not forward decal. It can't be a forward declaration, can it? Alright, so that's something we can check. Gotta dump it to disk somewhere there. My days. Sorry, I miscat it. I want to. Where's the thing we run HCC? This one. Can we get a build that's not bugged? Okay, good. So I need to dump the output. Dash dash debug AST. Dump it to disk. So we open that up. This is just a pure dump of the whole AST. Now we go to the shader we was trying to. It was right atomic add. Right, here it is. So the call. This is the call. It's a forward declaration. So that's the reason why we can get it to trigger. Why is it a forward decal? So it gets resolved later then. Okay, now remembering how my compiler is. But as you see there, it needs a pointer. And that's the type of it, it's a function type. So that's the reason why we couldn't get a breakpoint in here. It would kind of be nice to know. So it gets patched later on, basically, this forward declaration. It gets patched. So how can I put a breakpoint in to figure out what's going on? I can just look for an int pointer here. That's probably the best way to do it, isn't it? Pointer deduplicate. We're deduplicating from a UN, is that right? Unsigned in. Yeah, so we want to HCC data type. I forgot what it's called now. AST basic. UN. That'll be it. So we want to get, like, we want to say, oh, if param equal TT, then put a trap down. And we should be able to debug that. Alright, we're in, we hit the trap. Finally. Now we can actually debug. That was too much effort. Alright, so now we've got this programmatic trap. We can literally just open up in GDB. We run this GDB. Wait, GF. There you go. Oh, look at that. We're in. Wait, no longer exists. Legal instruction. Wait, it's not the point of a trap. What's the other one? Did he just use a sick trap in what the crap's going on there? Oh, debug trap. Wrong one. That's the one you want to use instead. Debug trap, not trap. Alright. Anywho, so now we break. We're here, we've got all the context that we want, so we can hop in. And we can figure out why this doesn't return false. Source type, what? How's the target data type 6? Did it deep? So at the moment, target data type is 6. How's it 6? Doesn't make any Oh. What? Oh, maybe I've got a couple of these like this. This might be a different function call. I don't quite know yet. Actually, from a forward decal, could we get a name? You have names? You have an identifier string ID. Ooh. We could use that to tell if it's the correct. This is another way of doing it. If string table get can actually just do that and does it automatically for you for the decal. Now I don't know if we've got the string. String equal. What do we? So it's like atomic add E32. That's what I'm looking for in it. There we go. Function decal. Wait a minute, is this a B? W compute unit. Sorry, compilation unit. Right, so we hit the trap again this time, but now we know for definite is the right one. So let's try that again. Alright. So target data type is now 8198, which definitely feels more like the pointer type. It's a bigger number. Oh shoot. Alright. So now source. Why is source data type the same thing? We've only got one instance of this. Oh, we hit the trap again. I want to continue. One, two, three, four. I thought we didn't have any other atomics in the code base. Oh my days. There's only one use of this atomic. We should store the string and just see, like, just have a look at that and verify that as well, like. And if we're calling it 3 times, and yeah, so there it is. Continue. There it is as well. That's weird. Yeah, building a game. That's right. That's the idea. So why are we hitting the same? What kind of? It's gonna probably be an RPG. Oh. Ah, we're using atomic add in the printing code as well. So there's print. There's some printing. It's being compiled. Where's the print? Triangle. And the voxel ray tracer. So we'll comment those ones out. And the voxel ray tracer. Oh, I didn't even use it in it. Right, so we compile on that now. Okay, so how many times do we encounter? Still twice. Right, so when you do the print, call it here when, right? Oh, maybe it's in some print function, in an actual function somewhere in the standard library. Yeah, it's alright. Okay, so we've got 2 to check. It's better than 3. Alright, so the first one. It's probably not the first one, but let's just double check that. They are different. Oh, what is this? This looks different. Maybe I just misread it. If his pointer, if the target is pointer that we're assigning to, and the source type is a basic and an int. Why would we do that? I completely skipped over this. Why is this here? If the target type is a pointer, it's doing the implicit. This is totally wrong. So we need to comment that out and see why I put this in here. Like, maybe I was saying they should both be pointer types. I have no idea why this is that. This is here. Sure, let's go. And git diff it now. Right, so we compile that, it should error. Here you go. Mismatch, U32 does not cast to the pointer type. That's the error we expect. Now see if there's anything else that's a problem. No, that's fine, that error was there anyway. Okay. Oh, I didn't commit any of this code? Whoops. Added bit count and didn't commit it. Alright, so we need to remove that triangle point out. There you go. Okay, so added bit count. This should get deleted. I don't know why that was in there. Maybe the purpose was to sum some kind of value to pointer error in the Linux kernel. I don't know. It could be. Or could it be the string type that I've got? Maybe it's the string type. I'm gonna do the string. But no, we would see that be a problem because we do some printing in here. Yeah, I'm not. No idea. Maybe I just put it in there accidentally. Super weird though. That caught me off guard. Dude, what is that? Now I'm deleting code from my code base. That's up here. Alright, nearly there. We get this in and then all of our shaders should actually compile proper. So we had a bit count, intrinsic, and fix atomic. Yeah, I guess I'll commit that later. But that compiles now, so let's compile a release build. So an optimized build basically. I'll grab that, put it in the code base, test it out, and then I'll commit. Oh, wrong place. HCC build, let's just grab the executable, that's all I need. Go into the GameVer engine. Put that in there. Yeah, so we just hit compile. Go to the shaders. We'll remove that. Do we get, yeah, we get a proper error now. Right, so it's saying here that mismatch U32. Good. So all those if zeros I put in, I think I removed them. Okay, so I'm glad that was actually not a lot of work to do. It's just a bit of a pain to debug. Because I kind of had forgotten some of the bits of the code base. Oh, Amadeus, there's another problem. Oh, what is this? Identities passed to must be of type integer. So it thinks it's a variable. How can this thing not think it's a function? Yeah, exactly. This is weird. Oh, right, I've ended. This is declared in local scope, that's why. Alright, still got out of bounds error. Yep. Let's go hunting. Alright, good, good, good. We found the area. It's somewhere in here. That's the problem. I don't know what it is though. Is it this block here? Okay, it's within that block there. Excellent. Let's keep drilling down. So yeah, if we just enable this, you'll see pops up with this area here with the access chain in the SPIV code. So let's right, that compiles, which means it's something in here. Interesting. So this, right, that's a Boolean. That's why that Boolean doesn't convert. Is that a Boolean? Should that be returning a Boolean type? I don't think so. Now that should... Wait, what does that return in C? I think it returns an int. forgot. So I think that's an issue, that's the problem. So what type does? Well, you can find out, right? You just go to Godbolt, and you just literally use the type of operator. Oh my days. You can use type of, can't you? You can say lang. Oh, what the hell's going on? C. Static assert. I think there's a thing called like type same. I think there's the one called type same or something like that. Built-in type same. Maybe. Huh. Man, I remember this built-in, but I cannot think of the exact name. There's a built-in. There's an extension. That's just been on there though. So I just want to check to see based on the comparison operator. Your type's compatible. I think that's it. Yeah, that's it. So it's a GCC thing. That's probably why it didn't come up. Because these are like probably Clang specific things. That's the one. Thank you, Clarissa. Appreciate it. So we just want to say, hey, if type's compatible, type of one greater than 2 and int. That's all I'm looking for. I don't know what it's complaining about. Can I go to Clang? Go latest Clang, see what happens. Right, it doesn't like static assert because it's got to be the C1. All right, that works apparently. So if I say bool and I include, wait a minute, just do the proper C1 in it. Yeah, so this one failed. So it is an int. So my compiler, I'm making it become a ball, I think. And it's meant to be an int. So that's the reason why it's trying to index that with a boolean. By the looks of the error. It's saying that it's got to be an integer type. But it's not an integer, it's a boolean, right? So if we hop in the compiler again, and there's the operators. Yeah, thank you, sir. That was great. Operators. Where are the operators? So that's just a binary expression, binary op. So you do like precedence. There we go. So based on the precedence, there's a comparison thing somewhere in here. Logical? Is it logical? No. Compatible arithmetic, left, right, expression is taking them both in. Right, so this thing looks like it can mess with stuff and bugger it up. Oh, not arithmetic. It's not, oh, wait. Sorry, I was thinking about the wrong thing. I'm looking for a comparison operator. Let's go back up here. Cool, no. Else, subscript, no. Field access, no. Ternary, no. So fall down in here. If it's an assignment, it's going to be arithmetic. So I guess it'll be an arithmetic then. Alright. So they're both basic. Does all the ranking crap. Yeah, so this is all correct, I'm pretty sure. Where does it explicitly say it's of a... Huh. So one way to check would be look for any equal operators anywhere or not equal. Haven't got any of that in the code base. So voxel ray tracer has double equal. That should be showing up. What would that be under? That would just be I forgot it's called, like a binary binary op. What I called it now. So just look for equal. Yeah, see, it returns a boolean. Yeah. When you do equal, it returns bool. That's not C, is it? So I think it should be returning a I don't know how it's doing that. I don't think it should be returning an int either. Say if these are both unsigned. Oh, it does return int as well. What happens if they're longs? It always just returns int. Fair play. So where is this happening? Because it's not assignment. Right, what this data type thing here? Ah, if it's equal. Right. Do ball. No, 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 no. Int. There's the fix. Didn't I call it sint or something like that? Sint, yeah. That's the one, right. So that'd be the other fix. So we're gonna do a release build of that. Grab that over. Overwrite that. Rightio, so let's give that another spin. So this time now we're gonna bring, yeah, this should just be fine now. Uh-oh. Invalid conversion from abstract machine language 15 to 1. So 15 is probably the int. Sorry. From op conversion. Oh, maybe this is because the conversion code doesn't handle going from int to Boolean. It should. Oh wait, with type class. Oh yeah. So I guess that's in spivvy gen. Here we go. So 15, which is probably one is Boolean. What is that? 15, is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Subtract on a Boolean. Why is it subtracting on a Boolean? And also, so higher up, if you have a Boolean type, it should probably just be turned into an integer. But that's probably through the integer promotion stuff. So that's arithmetic. So with the arithmetic stuff, you've got a left and a right, and so the Boolean, so if either of them are float, if not, they're both integers. And if the current rank is less than, so is the Boolean is rank 1 and int is rank 4. This is like proper legit C stuff, where does that integer promotion thing. So it should be fine. It should promote to ints when you do any operation. So where is there any code that's being generated, which is a subtract on two Booleans? We can find that out by doing another one of these dumps. But oh, this one's failing on a bitwise and now. in this code base. I didn't read it. So bitwise and is that one of these a boolean or something? So I think what's happening with this one here is the boolean is expecting it to be a boolean in the spivvy code. So we grep sorry, if we cat the spivvy dis, that's what I meant. I mean grep for, you'll see that one of these is a boolean. So that's an integer. Right, that's a bool. So what's happening in that code that we edited, sorry, not the one that we edited, in here, when we do one of these like logical equals, no. Yeah, maybe something to do with the binary op. Maybe it's the same bug actually as the other one we come up was just looking at as well. What's probably happening is the integer promotion maybe. So we can dump a new AST. So I've got a new AST now. So we look for a bit and we're looking for the one where it's got a right hand side of a boolean. So left hand side, right hand side, I think. No. Yeah. So left hand side, right hand side. So looking for one where it has the right hand side of boolean. There's over 99 of them apparently. Great. So let's go towards the bottom and go up. Probably more likely to be in the user code than it is the it was a bitwise and, right? Yeah. But now we're just into standard library functions. So there's just a bunch of repeats. So maybe it's in the standard library code. So there's a boolean as a second field or something. Which is not very easy to search for. There's a lot of booleans in the code base. And if it just followed the and, it would be easy to search for. Hey there, Tinspin, welcome. Welcome back, how you doing? Yeah, not doing bad. So we've got our shaders compiling, and then, well, we didn't actually get them fully compiling. We've got a few little compiler bugs that we just fixed in. One of them was some remnant. One of them was the atomic type check was a bit buggered. For some reason, it wouldn't tell the difference between a pointer and a non-pointer type. But we fixed that. And this other one is coming from, I was converting this expression to a boolean, and it's actually meant to be an int. So it was kind of messing up in the spivvy code gen. But we're just trying to fix some of those bugs now. But yeah, today we've finished up all of the shaders for the constructor for this 3D volume of spheres. Yeah. So it now constructs a 3D volume of spheres, but we're still going to try and run it. Yeah, it converts them from a list of like edit operations, and it will sort of, it's kind of like a way of saving memory on disk, and then sort of when you load up the game, you sort of evaluate all of these edit operations that fill in these volumes of spheres. So we've just got that whole swath of shaders sort of like compiling again. So just got to fix these compiler bugs, and then we can start testing it out. Just trying to find this problem with this Boolean bug. So one of these has a Boolean second argument. It uses a fire node, which makes me think we're looking for a ternary operator, because we don't put fire nodes down, except for ternaries, right? There's only one fire instruction we put in. No. What about the abstract machine language? We've got a fire in there, right? Basic block parameters. Oh yeah, sorry, we've got basic block parameters. Oh, we've got a few of those. Yeah, I can't. Yeah, we don't have fire nodes in our abstract machine language. We do basic block arguments instead. Right, I have no easy way of tracking this Boolean thing down. I say there's a whole ton of those. We could try and find what function this is in, I guess. Oh, let's just tail it. Tail. That's what I meant. So looking at like 4, 5. 4, 5, 3, that's the one. 4, 7, 8. That's in the triangle pixel shader. So that narrows it down a whole lot. Okay, so there's an AND operation here. Ooh. Boolean. Are these really Booleans? Because in these AND ops. And I could have swore that we said that those are meant to be. Ah, that's a Boolean. Right. So it's and a sign. So it's that triangle. Right. So I've got this like logical. Yeah, so it casts that into an integer, as you would expect. And then it casts the final result into Boolean. And this is all casted into an int. Right, but this logical AND in SPIR-V returns a Boolean. That's the problem. So these when we generate these, okay, it's the same problem. When we generate these in SPIR-V, the way the SPIR-V spec says is they probably return bool, right? Op. Right. I know the exact problem. Um, yeah, so I wonder if I should do it in SPIR-V code or do it in my abstract machine language. Maybe I do it in SPIR-V. Alright, here we go. So basically, if we get any of these ones here, they should return int instead of a bool. So we need to do a special separate instruction. So possibly what we should do is take these out of here. Put them in a separate case. But copy this whole implementation. Let's clean out the ones we've copied out. Clean out the ones we don't want. Okay, so with this one, when we translate from our abstract machine language down into SPIR-V, we still generate grab the right SPIR-V operation and then use our sort of instruction builder and generate, like convert over from ours to the SPIR-V one. But we need to do another instruction. So there's a return type param, there's a return what's it called? Logical equal. So this takes two booleans and returns. So the first one takes the return type. So there's that one, that's the return type. And then that's the result. So the thing is about the result, we need to actually do something like this, right? And then you start that on 2 plus. Wait. No, that's right. 1 plus that. Yes. Now you need to manually encode 1 in here. But instead of being a convert operand, it needs to be a new temporary one. Now I forgot how I did this. Yeah. Right, so you just make a sort of temporary. I forgot what I called these usually. But you allocate a new SPIR-V ID, result ID, call it. So what we're going to do is say, hey, whatever this instruction was, for this one that did these sort of like comparison operations, put it in this result ID register thing, right? and do the rest of the operands, so it would just stick in operand 1 and 2 basically. Maybe they're all the same. Yeah, they're all binary ops. So what we could really just do is do 2, that'll be 1, and then 3, that'll be 2. Get rid of the loop. Now, what we need to do after that is generate another one of these. So the thing is, this would be a Boolean as well. The return data type on this is a data type abstract machine language intrinsic Boolean. So then that will get converted into a SPIR-V data type and deduplicated, put into there. Now this one, you need to do the conversion into an integer. So there's a thing called like a select instruction. Something you can just do. One of these. So we'll generate select, and we just want to generate 1 or 0. So we want to use the result data type, which is going to be an integer. Though we know it's going to be an integer, so why don't we just hard code that in there. Well, this should also be lowered as well. Things. Let's put the return data type in, that's fine. So, result operand, call that. Then the source. Oh, right. The result is operands 0. There we go. And that'll be it. So that should be the necessary code now. So I convert that to an integer into the right register. Okay, so let's take that for a spin and see if we fixed it. So we hit to do. Now I hit a to do somewhere. What's that about? Right. So it's not, okay, so it's not lowered. Right, okay, that's fine. So this just needs to get lowered somehow. I thought this would lower, it seems like that lowers it. So you need to say like, so we lower it from the C data type, which is an int long short, to some abstract machine language one, which is more like U32, U16. So lower something like that. Still hit the to do. Man, seeing C code after working 4-day using Python feels like a should get magically removed. Yeah. Yeah, I don't know how people manage program Python without data types. Like, whenever I've tried to do it, it just gets pretty hard. Not gonna lie. It's painful coming from low level development, I can imagine. I know people really like it, and you know they build little application or little console apps in it, but why isn't this bugger working? If it is an intrinsic and is a scalar, do this thingy. Bob's your uncle. Are we hitting the same error again? Uh-huh. Why, you know... 686. Lower. So what data type is the return type then? That is the question. Oh, I've got to do like a standard error thing. Because otherwise the thing's gonna show up in the terminal. 513, and then this was like 16.8. Nice. Ooh, wait. That's not equal. Not equal. What? Oh. Oh, it's a resource type. Right, I see. There's already been a load, I think. Holy moly. No, it can't be. What even is that? Data type. Figure out which one of those boys it is. 1. Abstract machine language, exactly. In what funny world am I living in? Built-in... No, I can't do that. So it's being passed into there. It's got 1, which one means abstract machine language. And is scalar. Right, it's not a scalar then. Is it then vectorized? Is that the idea? Like one of them... I don't have support for that. So print out another integer. I don't think we have to lower it, it'd be a waste. And be confusing if we read over the code again. You're gonna have to do it. Right, it returns 33. That's a vector 2. Which code does this? And gets away with it? There's code that gets away with this. So again, in that sort of comparison, Not compatible arithmetic, but maybe. Yeah. So it is arithmetic, isn't it? Yeah. But how can the return data type be set to something that's not an integer for these ones? Because we go to abstract machine language. One of these guys. Um, it's a Boolean times 3 on the right hand side. Wait, it's on as the return type, Boolean times 3. Did I add support for that in the compiler? I don't think so. I didn't add support for that. We've also got the and or stuff to fix as well in the lowering. I just remembered now. But that is extra weird. So it's maybe when it generates them, what's the data type? Result operand. Okay, if it's less than or equal. Oh. Shouldn't be Boolean. Um. AST basic signed in. Let's try that, see if that improves anything. Right, we're still getting the same issue. How is the left data type for one of these guys on a binary op? Like 33, which is probably a Boolean times 3 or something. And also getting away with it. We've got a break in the previous statement. It's not the problem. So it's a Boolean. So if the left is a constant and or an or, oh, as Boolean. Right, okay, it's fine. Needs to be an int though. See, casting it into Boolean is wrong. It needs to be. It needs to be made into an integer. So it needs to be an equal operator. This needs to be an equal operator with a constant 1. Or not equal 0, I mean. Binary. Left expression needs to be. See, it's a bit of an optimization. I could just get rid of it. No, I think I need to. I could just get rid of it. It's an optimization that we don't really need to do. Because it'll get caught later on anyway. Let's just do that. That'd be easier. Is anything else with booleans around here that's just messing things up? Alright. So somehow one of these is being generated. Yeah, somehow there's like an equal or a not equal being that's being generated somehow. One right here, convert to Boolean. So it's actually converting. Right. It turns out this equal thing works on not a scalar but vector data as well. So I guess we need to support that. Although I didn't really support it here when I did this. So this is kind of vectorized. This return data type could be vectorized. And if it is, that needs to be vectorized. But how do I generate a constant? Well, anyways, when I did this convert to Boolean though, what thing? What code is converting it into a vector of booleans? Not bit not. Right, so it's just some of the intrinsics do this behind the scenes. So what is it converting the source operand, which is the parameters? Yes, it's converting the parameters. So if the scalar, sorry, if the, so you're doing like an any or an all. Right. Okay, so to support any type, we do the convert to Boolean. Okay, I see now. And it does that with an equal operation. Alright, so we have to support that in here. What's the easiest way? So you basically just need to make a constant, like a vector of that. If it's scalar, do we have one of these for like vectors? Composite, data type fields, that could work. Yeah, I think it could work. We can add one else if it's not a scalar, right? Then if the number of rows is equal to 1. So this is a vector. So you get the number of columns. Number of columns. Then you will simply get the constant. So you just get the fields. There's at most 4 of these. No biggie. Then you go over all of them. Well, you just fill it up regardless, right? No, that'd be fine. So you're just filling up fields with effectively the single constant. This is what the single sort of where you want it, right? You need to get the scalarized version of it. AML intrinsic scalar. You can tell it to just give you the scalar version. And then, yes, generate the 1 constant. and then you simply just assign all the fields to that, and then this one is a composite. The data type is one you passed in the array of fields, and the number of fields is columns. Call it fields count maybe. Alright, there you go. So that should generate ourselves a one constant for vector types, and we need the same thing for 0. Which is just above here. Just give that a go. Okay, so that compiles now. I wonder if is it going for any of this code? 2.6. It's not going for any of the code we've just done. So try to deduplicate it and it fails. So we got, does it, so I've used this before. Oh, I see a bug. The data type was out of bounds. Why? Huh? Oh, okay, there's an extra bracket there. Right. Okay, so now we're on to a different one. Expected basic type begot float 16. Is that in the same sort of code that we've been looking at? Not sure. 223. No, this is not the right one. Oh, machine language. So this error is from 477. Oh, it's landed in here. But shouldn't it have landed in here or something? Um, Wait a minute, how is this different? Yeah, that also just works. But still though. Right, this one was the line that was failing. But why was it getting F16 in the... Right, okay, maybe that's fine. Okay, so SpivvyGen 3, 5, 8. Oh my days. Can of worms. A simple store? No, convert... So you'd have messed with... Yeah, I think maybe there's something wrong in one of these. Um... No, 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 no. It's not the right data type, that's why. So we should probably call this scalar data type. And then we want to use that there, get the scalar data type, replicate it. Right, excellent. So now that's okay. I equals, and I just got the wrong number of instruction words, I think. So I equal. It's got one too many. Alright. So I equal. Oh, shouldn't be doing I equal here. Whoops. This should be select. There we go. And still got the same problem, maybe? I was expecting a select instruction to be there or something. We've added more. I forgot the number now. Is that 49 what? 191. So I think we just added more instructions, but we've still got 5 boolean. On that one there. So yeah. Yeah, because we didn't change the logical ands and that logical and logical or. So they're like these short circuiting operators. And it's just a convert to ball, so maybe, I wonder where they're actually used now. Hey Perry. Yeah, Australia was great, man. Yeah, went outside, got some sun. How you been? But yeah, lots of traveling, um, doing stuff every day basically. The plane was just so long. Um, and sleeping on the plane was basically impossible. So on the way back, I basically had like 4 hours sleep over 2 days. So yeah, it was hard. But the baby slept good on the second flight, not the first flight over. Yeah, man, it's been a while, hasn't it? It's been long. Oh, but yeah, been good. Just I think at the beginning of the week, I'd sort of get back to my sort of complicated life, and trying to get back into work and doing everything was just a bit of a system overload for the first 2 days. But from yesterday, it's been good. Sleeping on the plane just doesn't work for me. It was just naps, odd 20 minutes. Yeah, that's it. That's similar for me. And then you're waking up for food or something. You're like, ah. Hmm. Right. We're in a bit of a pickle with this Boolean thing. Can't believe it. Probably best to put a pin in it here because I think there's still one or two more things to solve. How's the mum and the baby? Yeah, yeah. Both doing well, thank you. Yeah, the baby's just like getting his two front teeth. Um and yeah, it's still not crawling yet. But it's a load of fun. Man, I can't believe we're just uncovering all these compiler bugs today. The chances. Oh. Um. Right, I think let's find somebody to raid because it's getting super late and I need to somehow get into bed. Yeah, man. Is awesome. Like, it was actually just a lot of fun just spending time with them both just on holiday. Um um Man, who can I raid? I could just raid Lost Mars. Okay, so watching movies. Classic. Man, I'm so damn tired. Building game engine from scratch. Here we go. And I bet you it's in Rust or something. Nah, C++20. Fair play. Ought to be good enough. I think is he gonna watch some Lord of the Rings or something? I don't know. It looked like looked fantasy, so I just pulled that out of the back of my head. Right. Thanks for coming, everyone. I'll see you all in a future stream. It's getting late. I need to pass out. I'll next be on maybe on Sunday, probably Sunday, 6 p.m. GMT. That's the one. And we'll finish these compiler bugs, and then get the shaders compiling again, and be testing them out hopefully. Right. Have a good evening, everyone, and see you in the future one. Catch you later.